Only 39 students, you have to have more than 100. Where is the others? Do you have activity or something? Omar? So I will start. Our class is easy for today. So any question regarding last week? I will recap this one. We talk about strings. What is the languages? Am I sharing the screen?
Yes,
Okay.
doctor.
A string is a list of characters from a given alphabet. So, for example, A, B, C, and C, B, A are different strings. Are A, B, B, A, B. We talked about epsilon and phi. What is the difference between epsilon and phi? Epsilon. What is epsilon? Null string. Null string epsilon. Phi, empty set. Okay. Okay. Now we have epsilon 0, 0, 1. This is for language alphabet 0, 1. Finite state. We talk about finite state. Machine. FS finite state. We have like a graph. Okay. This machine accepts any strings of zeros and ones which begins with 1 and end of 0. Start with 1 and end with 0. And we have many examples of this kind of FSM. And then we go to regular expression. Okay, so regular expression is we can exchange between FSM and regular expression. We can make regular expression and FSM. So here we have plus means union. So A, B, C, A, B, here we have A, B, C, B, A. This is one union, means elements of here with elements from here, without repeating any element here. Okay. L plus empty set, this one we call it empty set. Empty set, this one, empty set. L plus empty set, L. Concatenation. We have A, B, C, B, A. We just pinned the BA to ABC. So you have null string S concatenate null string equal to S. This one concatenation. So if we have A, B, C, A, C, B, epsilon, so we have A, B, B, A, B, epsilon. So A, B, epsilon means A, B. And we have A, B, so we don't repeat A, B again. We write A, B one time. Because here we have A, B, epsilon. And we have A, B, epsilon. We have A, B, epsilon. And we have A, B, A, B. We have A, B. This one, the phi. Note that L1 are two languages, then L1 concatenate is not necessarily equal to L2 minus L1. Also, L concatenate epsilon equal L, but L concatenate phi equal phi. Cleaning L power 0 plus L power 1 plus L power 2 plus L power n. Okay, here this is the cleaning. Okay, phi cleaning is null string. Here we have L1, L2, and L3. Then we have L1 plus L2 concatenate L3 equal L1 concatenate L2 L3. So here this one L1 L2 concatenate L2 equal to L1 union L2 concatenate L3, and L1 concatenate L2 star equal to L1 concatenate parentheses. So here we add the parentheses. Here we add the parentheses for L2 concatenate L3. This one we talked about regular expression. An example of regular expression is you have this alphabet 0 plus 1 Glini. To understand what these strings are in the language, let L0 1. We need L star, L cleaning, or L closure. L power 0 epsilon, L power 1 0 1, L power 2 L 0 0 1 0. Here L power 3 L concatenate L power 2. So here we concatenate. So L star we have union this one and this one and this one and this one. The set of all strings of 0 and 1s. Another example here, N, here 0, here all strings start with 1 and end with 0. The set of all strings of zeros and 1s which begins with 1 and end of zeros. This is the regular expression. Note that we don't need to be concerned with the order of the evaluation of level concatenation in one regular expression since it is an associative operation. The same is true of union. L concatenate L equal LL concatenate L, and L plus L equal to L plus L plus L. So here for the 0 1 0 concatenate 1 concatenate here. Here we have to review this one. Okay, here we have each following regular expression list 6 strings which are in this language. We have started with A and end of D. So here start with D because here star of A means start with lambda. Start with lambda. Lambda D means lambda D. So this one for A 1 2 3 you can review this one. A star B star all star equal A plus B star. So you can solve your assignment your homework using this kind of example. Give a regular expression for each of these languages. Describe the same problem. Here we have solutions. Here we want to give a solution for 20A from the example in the book. Then we go to lexical tokens. We have words, we have keywords, and we have operators, we have numeric constants, we have character constants, we have special characters. We have commands. These are lexical tokens. White space, new line. We go here. We talk about the token here. We have Y token class 1. Parentheses token class C 6. So here for parentheses token class 6. Token class and what is the value? What is the class and what is the value? We get the symbol table. We talk about constructing the symbol table. Then we go for this code. We have an example for infinite. For accepting state, we did this one in the lab. Accept and check. We have this code. And we talk about the action. If you have L and D here, letter and D means letter or digit. Here, start from here. If it is letter, after letter, what is here? We have digit. And then we have here all transition are to be the dead state here. Here state machine for analysis for accepting words. Here this one, if. Here import. Here integer, int. Here float, for. Here float. Then we talk about actions for finite state machines. Actions means we have a function. We have a function to do to move from state to another state. We had this number. We have this example. If it's digit, go here. If it's digit P2, go here. Then if it is dot, then go here. If this after that digit, here we go. If it is E, letter E, go here. If it is E, go here. Here plus minus, go P4, D P5, and we define the function, the actions. We did this one last week. So input minus 1, expression D. This one P4, P5 here. We define P1, P2, P3, and P4 the function, P5, P6, and we start here. This is how to get the result. Math.power 10 sign expression minus places power xy math here. Then here we have this number. This string means 0.012987. We did this one. If you have input 1, the action will be equal 1. Everything is going to be changed. D n places expansion sign. If you have input 2, we have digit to go to P2, and this is the P2. P3, if digit also we stay P2. If dot, we have to go here. Okay. Then we talk about lexical tables. Sequential search. We have binary tree, how to build the tree. Starting from the word is the root. Then you have frog. After frog, we go if T, we go right. If less, we go left. And if it is more than the ASCII code for T is greater than F, go to right side. We talked about binary search, and we have balanced and the problem of balanced tree. Binary search, in the best case, we have O(n) log 2, binary log to n. In worst case, we have n or big O n power 2. Hash table. We start with hash table. We have here these words, and we start getting the first letter of this. We have array of list. We have here 1, 2, 3, 4, 5, 6. So 6 list of array of list. Okay, then we start from 0 to 5. Then we divide the ASCII code of the first letter of the word. If it is divided by mode 6, means mode not divide, means mode, the remainder. The remainder is 4, we start with 4, frog. If 30, the first letter of 3 is 4 means 4 digit of the word, and this is the first letter, first digit, and this is the 102 is F in ASCII. 4 means frog, 4 letters. 3 here, 4 letters. Hail, 4 letters. Bird, 4 letters. Bat, 3 letters. And 98 is the ASCII code of B. So here 3 plus 3, mode 6 means the remainder should be, what is this remainder? 5. So here, if 3, if it is here 0, we go 0. 0, here we start here. This one, we call it hash table. Now we go to our topic for today. Sabal CC and Java CC are two popular utility. Please, we review now all the sub topic for, for last 2 weeks. So here we have Sabal CC and Java CC are two popular utility programs for lexical analysis using Java program. Sabal CC has several advantages over Java CC. Sabal CC is designed to make good use of the advantages of Java. It is object-oriented and makes extensive use of class inheritance. With Sabal CC, compilation errors are easier to fix. Sabal CC generates modular software with each class in a separate file. Sabal CC generates syntax trees from which atoms or code can be generated. Sabal CC generates syntax trees from which atoms or code can be generated. Syntax tree and atoms. Sabal CC can accommodate a wider class of languages than Java CC, which permits only LL1 grammars. We will go later in what is the LL1 grammar. The input to Sabal CC consists of text file named with a .grammar suffix. So .grammar, which 6 sections: package declaration, helper declaration, states declarations, token declarations, ignore tokens, productions. Okay, so the grammar file consists of these sections, 6 sections. The file with .grammar, the file with .grammar. We will have example here, don't worry. The sections on the helper declaration states, and token characterization are relevant to lexical analysis. The input file named language.grammar will be arranged as shown below. Okay, we have here package, helpers, states, tokens. We'll go here step by step, don't worry. Token declarations. A token declaration takes the form of token name, token definitions. For example, left parenthesis here. A token definition may be any of the following a character in single quotas, such as W, 9, or $. This one, token definition may be any of the following character in single quotes. This one will give me a token. A number written in decimal or hexadecimal representing in ASCII, representing the ASCII actual Unicode, called for a character. Thus, the number 13 represents a new line character. The character new line works as well. A set of characters specified is in one of the following. Wait. So here we say left parenthesis, this one. A token definition may be any of the following: $9, a number written in decimal or hexadecimal representing the ASCII actually Unicode or for a character. Thus, the number 30 represents a new line character. The character /n works as well. Lexical analysis with cyber CC token declarations, a set of characters specified in one of the following ways. A single quoted character qualifies as a set consisting of one character. So a set of characters specified in one of the following ways. A single quoted character qualifies as a set of consistent of one character. A range of characters with first and last placed in brackets. Here are examples. A to Z, all lowercase letters. 0 to 9, all numeric characters. 9 to 19, all characters whose codes are in 9 to 99. The range 9 through 19 inclusive. 9 and 19 is inclusive in these brackets. A union of two sets specified in brackets with plus as set 1 plus set 2. Example, here AZ represents all letters from A to Z plus A to Z. This one give me the all letters. Group small letter, a group of capital letter. A difference of two sets is specified in brackets with a minus as in set 1 minus set 2. This represents all the characters in set 1 which are not also in set 2. Okay, here 0 to 1 to 7 minus /t plus /n represents all ASCII characters except tab and new line. Except tab and new line. So here, tab and new line, we expect except. So minus represents all ASCII code. So ASCII here, ASCII from 0 to 1 to 7. We remove or accept here T and N. A string of characters in a single quote such as while. Here, a string character in a single quote such here one word. While. Start here the quotes and then the quotes. This one we call it string of characters. Regular expression if P and Q are token definitions, then so are this called parentheses may be used to determine the order of operations. PQ, the concatenation of two token definition is a valid token definition. So parentheses may be used here, regular expression. If P and Q are token definition, then so are parentheses P may be used to determine the order of operations. The order of operations, what is the priority? The concatenation of two token definition is a valid token definition. The union of two token definition, note that plus symbol has a different meaning. So plus here is different meaning than union in token declaration. Here P union Q. Regular expressions, if P and Q are taken here, P star, the closure, cleanie, that we have here, is a valid token definition representing 0 or more representation of P. Okay, so we got the cleanie and we replace P with the P star here. So, P plus, similar to closure, represent one or more representations of the definition P. P plus, not like we had here. Okay. So the closure is valid token definition representing 0 or more. Similar to closure represent P plus. Here we have to consider about these rules. If I have star, the closure cleaning star is valid token. Definition representing 0 or more representation of P. So maybe I have P, maybe I have many repetition of P. Or there is no P because we have representing 0 or more representation of P. P plus similar to closure, but represent one or more representation of definition P. So you have at least one or more repetition of definition P. Here, clearly means 0. Maybe we don't have P. But in one, P plus means we have at least one P. P question mark represent an optional P, either 0 or 1 representations of the definition P. So here we have represents an optional P. That means 0 or 1 repetition of the definition P. So here this one is optional. The question mark is optional. 0 or 1 means appear or doesn't appear. If S1 and S2 are sets, S1 plus S2 is their union. S1 plus 2 is their union. If P is a regular expression, P plus is also a regular expression. To specify union of regular expression, use this sign. Number 0, 9 plus. A number is 1 or more decimal digit. Here a number is 1 or more decimal digit. So because we have plus. Identifier. So here this is number. How to define number? 0.9 plus. How to define identifier? Here we start with identifier. We have to start with the letter A Z. So here the letter identifier A Z here A09, and here underscore star. An identifier must begin with an alphabetic character. So here this here starts with alphabetic identifier number. An identifier must begin with an alphabetic character. A relation operation. Okay, here we have equal, minus, less than equal, and rather than equal. So here we have less than, plus, greater than, plus, question mark. Here plus sorry, plus equal, here equal, and not equal. 6 relational operators. What is the 6 relational operators? What is the 6 relational operator? We have 1. Okay, here we have the okay. Try to find the 6 relational operators here. Here, 1, 2, 3, 4, 5. Here, so we have 6 relational operator. We have 1, and this one union. 1, 2, and 1, 2. Here, less than, and greater than, and also less than, equal. Okay, less than, equal, greater than, equal. So here this is optional. So maybe this letter comes with equal, or this one comes with equal. So here 1, 1, 1, 1, 2, 1, 2. So here we have 3, 4, and 5. Here we have 4. 5 equal, and not equal are 5. And then we'll check the 6th one is the plus. When two token definition match input, the one matching the longer input string is selected. The longer input starting is selected. When two token definition match input strings of the same length, the token definition listed first is listed. First is listed. Definition of token first. If they have two token definition match input strings of the same length, the token definition listed first is selected. First one is selected. When the token definition match input, the one matching the longer input string is selected. We have here AZ plus and keyword while for class. This one keyword, this one tokens, identifier. Identifier, and we have keywords. Token declarations. An input of Y would be returned as an identifier, as would an input of while X. Instead, the token should be defined. So here we have while. An input while would be returned as an identifier, as would an input while X. Here we have a syntax error. Instead, the tokens should be defined as tokens keyword identifier. Yeah, here we have identifier keywords. But then here tokens, we start with identifier and keywords. But here we make the opposite. We start with keywords, then we go to identifier. We start with keywords and we go to identifier. With this definition, the input while X will be returned as identifier. So here will be repeated as identifier. So you notice what we did here? The definition here of tokens, identifier keywords. But here we have keywords, then identifier. With this definition, the input while X will be returned as identifier. Helper. We talked about tokens. Now we talk about helper. Any helper which is defined in the helper section may be used as part of a token definition in token section. So any helper which is defined in the helper section may be used as part of token definition in token section. Helpers, here we have digit 0, 9, letter AZ plus AZ capital, sign plus minus, means union, this one, new line 10, 13. Here the tab and the ASCII code of new line. Tab 9. A new line is N13 and tab is 9. Tokens. We have here sign, question mark, digit plus. A number is an optional sign. A number is an optional sign, followed by one or more digits. So here, sign. Any number, it comes with plus or minus. And it is optional. It is optional. Digit plus. So here means sign, means any negative or positive words, or if there is no plus or minus, it will be also because here optional, is optional. Identifier, letter, union, digit, union, underscore, star. Identifier is a letter followed by 0 or more letters, digits, underscores. This one, letter, digit, underscore. Identifier is a letter followed by 0 or more letters, digits, underscore. Space. Here. New line and tab. Here we have space, new line and tab. Here, show the sequence of tokens which would be recognized by the preceding definitions of the number. Identifier and space for the following input. Also show the next which corresponds to each token. So here we have sample problem. During this problem, we are going to understand whatever we have. Show the sequence of tokens which would be recognized by the preceding definitions of number, identifier, and space for the following input. Also show the text which correspond to each token. We have this input 334 space ABC and ABC 334. Number 334 space identifier ABC space here 334 number space identifier ABC space and identifier ABC 334. This one show the sequence of tokens which would be recognized by the preceding definition of number, identifier, and space of the following input. I show of the next which corresponds to each token. State declarations, left context and right context. State statement 1, statement 2, statement 3. The first state listed is the start state, and the scanner will state out in the state. The first state listed in the start state, the scanner will start out in this state. So here we start with the first state. In the token section, any definition may be preceded by a list of state names and optional state transition in curly braces. Okay. We go here, don't worry, we'll discuss here details. In the token section, any definition may be preceded by a list of state names and optional state transition inside curly braces. Set declarations, left context and right context. The definition will be applied only if the scanner is in the specified state. Statements token equal diff. Apply this definition only if the scanner is in the statement and remain in that state. So apply the definition only if the scanner is in the statement, state name, and remain in the state. A transition operator. Transition operator may follow any state name inside the braces. Here, state name, new state, token definition. Apply this definition only if the scanner is working. In state name and change the state to new state. So here, state name, new state, token. Apply this definition only if the scanner is in the statement and change the state to new state. State declarations, okay, we complete here. The definition may be associated with more than one state. State 1 to the state 2, state 3 to state 4, state 5, token definition. Apply this definition only if the scanner is in state 1. So state 1, state 2, state 3, state 4, state 5. Here, apply this definition only if the scanner is in state 1, change to state 2, or if the scanner is in state 3, change to the station state 4, or if the scanner is at state 5, remain in state 5. Remain in state 5. Definitions which are not associated with any states may be applied regardless of the state of the scanner. Token definition, apply this definition regardless of the current state of the scanner. State declarations. The following example is taken from the CSC website. Its purpose is to make the scanner toggle back and forth between two states depending on whether it is at the programming offline in the input. Again, the following example is taken from the CSC website. Its purpose is to make the scanner toggle back and forth between between two states depending on the on whether if it is at the beginning of a line in the input. Here we have states Boolean in line. Declare the state name. Names Boolean is the start state. So Boolean is the starting state. Boolean in line. Character 00x minus 10 plus 13. Scanning a non-new line character. Apply this in either state or new state is inline. So here B Boolean inline. Here we have the Boolean EOL1 EOL1 equal 10 and 13 and 10 3. 10 3 13. We'll check here, don't worry, because this one we have 10 13 and we have 10 13. Scanning a new line character, apply this in either state. New state is Boolean. Show the token and state definition needed to process a text file containing numbers, currency, values, and spaces. Currently, values begin with a dollar sign, such as $3045 and $9. Assume all numbers are current and currency values are whole numbers. Your definition should be able to distinguish between currency values, money, and ordinary numbers. Okay, you may also use helpers. We have currency and we have digits. Helpers 0, 9 plus here, or 1 or more digits, because we have plus 1 or more. If 0, maybe happen or maybe no. States, we have diff currency. Tokens, we have diff currency tokens. Definition is start state. Start state. Okay. Here we have space, blank, I mean tab, 10, 13, /T. Diff currency dollar. So here we have space and currency definition money equal num. Here change to currency and here change money to num. Definition number equal num. Definition number equal num. Okay, package LECT5. Here we have this code in the text file that I've shared with you last week. A Java package is produced for the generated scanner. So helpers num equal 0 to 9 plus here a number is 1 or more decimal digit. It is this one different. A num is 1 or more decimal digit. Letter alphabet. So here a letter is a single upper or lowercase character. Single upper or lower single upper or lowercase character. Here we have number equal num. So now, okay. In the example would be Kirill, don't worry. Tokens number equal num. A number token is a whole number. Identifier is a letter union number, Kilini. And indent token is a letter followed by 0 or more 0 or more letters and numbers. So starting with letter followed by any letter or number. Arithmetic operation, we have plus, minus, plus multiplication, divided. Arithmetic operators, this one arithmetic operation, this one arithmetic operator. Less than, we have to have 6, am I right? Less than, greater than, equal, less than equal, greater than equal, not equal. So we have 1, 2, 3, 4, 5, 6. Okay, we discussed here this one in the previous slide here. This one, relation operator here, less than, here optional, less than equal, less than, or less than equal. greater than equal, and equal and not equal. So this one 6. So here real operation means this here less than equal or less than here 1 2 3 4 5 6. So less than equal, greater than equal, and less than equal and greater than equal. And here this is the relational operation. This one we call it relational operation. This one arithmetic operation. Parenthesis, blank, these three letters for blank, and new line, new white space, here. This blank slash t 10 number 10 or slash n means white space. Any single character which is not part of one of the above tokens here we have package lexing for lexical analysis. Import here the code. Import lexer star, node star, IO star, start lexer, start static object token, public static void main string. Here lexer, new push back reader, new input stream reader, system.in1024 token equal null. This is the first code for class lexing. So we start here to read the number of variable. Here y parentheses not equal token instance end of file. Token equal lexical and dot next parentheses read next token. If token instance of t number, system out print line number equal. Else if token instance of t identification, system out print line identifier. Okay, now step by step you will understand what is going here. Else if token instead of t earth operation, here arithmetic operation. Here, if token installs of token real op, system out provide relation operation. If t real op means greater than, equal, so relational operation. Else if token instance of t parentheses, system out parentheses. Else if token instance of t blank, ignore white space. So here we go through this one. Through this one. We have number, token is whole number, identifier, then arithmetic operation, then relation operation, then parentheses, then black. Then if it is here, no, it's we call it unknown. Any single character which is not part of the one of the above tokens, we call it unknown. Now, Here we will go to lab and run sample CC LECT5 grammar and Java language, Java compiler, language name star Java, Java compiler with Java compiler, LECT5 star Java. We have now generating the scanner in LECT5 class. We'll do this through lab to execute the scanner Java language name dot class name. To execute, we have Java language name, class name. Okay. Running sample CC. Here we go to sample CC. I will share with you in the class videos to run the sample CC, running Java CC. This will read from the standard input file keyboard and should display tokens as they are recognized. Use the end of file character to terminate the input, or Control D for Unix, Control Z for Windows. Control Z for Windows to terminate the input. Java, here Java LECT5 example. Java LECT5 sum equals sum plus salary, identifier sum, unknown, identifier sum, arithmetic operator plus, identifier salary, unknown. So here we have unknown equal identifier sum operator plus identifier salary. In our course, this would be Java LECT5.LECT5. This will read from the standard input file keyboard and should display tokens as they are recognized. Use the end of the file character to terminate the input. Control D Unix control for Windows. Look at this example, helpers example. Here we have letters. W, we have digit. We have digit plus. So letter A, Z here. Digit 0, 1 number. Digit S, digit plus. Any number of numbers. EXP, union E, plus minus, optional digits. Here we have E minus 34. New line 10 plus 13, slash in. Non-star, here star complement. Non-star, here 0 to here minus star. None slash. Here we declare the star. We declare the division equal to dollar. A language which is not case sensitive, such as BASIC or Pascal, would require a different strategy for keywords. So if it is not case sensitive, the keywords could be defined as, the keyword would be defined as while, WWHHIILLEE. Alternative, a preprocessor could convert all letters not inside strings to lowercase. Comment one, if I have here, if I have to backslash, we have comment 1. So here, new line, comment 1. Comment 2, here star, non-star, backslash, star, here non-star, star. Non-star slash, non-star, star plus forward slash. Okay, so here we have backslash star non-star slash non-star slash non-star star and star plus here star means divide space here space union line here because this is empty. Tab. This is call it tab. When we got this tab here, number here. Okay, 0, 30, 9 here from 0, 9, 10, 13, and here 9. We have the new line. Class keywords reserved, public keyword reserved, static keyword reserved, void main. This one all words are reserved. String, here we have a string with capital, integer, int, float, for, while. So all of them are same. If, else, design, equal. Compare. Equal is equal. Assign one equal. Compare double equal. So we have compare equal, not less than, greater than, equal or less, equal or greater than or equal, and not equal. Plus, minus, multiplication, and division. One parenthesis, left parenthesis, right parenthesis, left brace, and right brace, and L bracket, and R bracket. So we have curly braces and parentheses, and we have bracket. Okay. This one, comma, semicolon, identifier, letter, digit, underscore, number, digits, dot means optional, digits, optional here, or here, union, dot digits, expression, here expression. So MIC. So this one, the last slide. Okay. So yeah. We'll go to the lexical analysis. We have you go through all the, okay, I will share the screen. We did this one, lexical tokens. Implementation of finished state machine. Then for lexical hash table. Sable CC. So we go for the tokens with Sable CC. Okay, we have here digits. And we have here some keywords. So identifier keywords while X will be accepted. Keyword then identifier while X will not will be identifier, not will be keyword. This one helper declarations. Left and right contest. Here the token. Here helper num, one or more digits, diff currency, diff start state, space. Now look at this example. Currency number divided by space star DB number divided by space star CR. In the text, your bill is 14.50 CR and you are 12 days late. Sable CC, I want to would define a currency tokens as 14.50 if it's excluded the CR, which is the right context. The 12 would not be turned as currency token because the right context is not present. Let us check this example. Here, this one file. This is the file of Lexing. We will run it during our lab. This one, the code. This one, the Sable CC language grammar. Here means the Java, how to run the Java compiler. So here, sum equals sum. Here, identifier sum equal is unknown. Identifier sum plus is arithmetic operator, identifier salary, semicolon is unknown. If we have inputs like this, please solve this one. Which token here will be? So the sequence tokens recognized by the following definition for each of the input files. Here characters AZ09 question mark. Token 1 character, token 2 character X, token 3 character plus, token 4 09 plus. Here means more than one digit. Space. I want you to make this, to solve this one right now. This exercise right now. So if A1, you have here character. What is the character? Character is a character followed by followed by number. So here token 1. Am I right? No, here token 1 character. So token 1 character. Character will have a number. Character number. So A1 will be character. B2, I have character too. So A1, B1, okay, B2, C3 is not character. So token 1 is character. So A1, B1 is token 1. C3 is token 1 or no? Okay. Here, if token 2 character X. So here, if we have AB3 is space. Here we have token 4. AB. So here, what is the meaning of question mark? What the meaning of plus? We means that many digits of numbers. We go here, token 4. A1, token 1, then token 4, 2, 3. AB. Okay, so here 09 appears 1 and more repetition. Okay, I want you to solve this one now to check how the input file is this. I want you to find the tokens. I want you to find the tokens. This one. Decaf. Decaf, we'll take this decaf later. So I want you to solve this exercise. What does it mean? Question mark. I will share with you another screen. So I want you to follow which is the output of this one. Token one, token one, token one. If it is like this, let me give you the question here. Wait. I think I had this question. I will share with you the screen. Okay. This is the question. And I give you two questions. Here we have this question, number 2, and here number 3, this second question, helpers, CN tokens. This one, question 1. And this one, the other one is question 2. Okay, this one, question 2. Another question. We have tokens, CN mean character number, character number. What does it mean, question mark? Represent an optional P, either 0 or 1 representation of definition number. Here, P plus similar to closure represent 1 or more. So here, what is the tokens here? For this one, if I have this one, BC9, B9C, BC, BC. So what is, which number token? Here, which token? Okay, please solve this one. Okay, any volunteer? Which tokens here? Any volunteer? This one will be in the test. I have helpers, I have input file, I need to take the output, which token 1, which token 2, which token 3, if the input is like this. This one question 1, this one question 2. Here we have BC9. BC9. Here BC9, B9C, and BCBC. So we have 3 input for the sample CC. Okay, I will give you 10 minutes to solve this question. You have 10 minutes to solve it. Two questions, question 1 and question 2. I have already shared the slides and the file with you, so you can refer your notes. Yes. You want to share the answer? Muhammad Hakim Azhar. Token 1, token 1, token 1. Okay. Token 3 for the third one, for the second one. ABC token 3. Okay. Token 3. Okay. Token 3 space token 3. Okay. C token 2. Okay. Space token 1 space token 3. Okay. Okay. For the last one, token 2 here, token 2, token 5. Could you explain, Muhammad Hakim? Could you explain on the board, same screen? How did you find this, Muhammad Hakim Azhar? Hello?
Hello, sir.
Yes. How could you explain how you find this result?
I just use that reference from that
Hmm?
token 1 equals to CN. I just use that reference
Which reference?
from the question, sir.
Explain here. This is the answer. You don't know how you answer it? Do you know how to answer this one?
Yes, sir.
Explain.
Oh, for question 2 or
For question one.
question 1. Question 1, for A, because of it use cha A1, so I use token 1, and then it use B2 token 1 again, and then C3 token 1 again.
Okay, but here the character is one character is alphabetical and number. Okay, not only alphabet. Here one character. If I say token one means alphabetical numeric. This one token. Token two, token one again, alphabetical numeric, because we have character, and one character is a consists of alphabetic and numeric. Do you understand?
Oh, okay, sir, okay.
Okay. You mean what I mean? You get what I mean? So one character is character and number. And here the question mark is optional for the number. Am I right? You have to check this one. Okay, I give you this one as an assignment 2. So you have assignment 1. Now this one assignment 2. Solve this question. So what's up? I share with you this folder, this file. What's up here?